In this video, let us solve question number 7 of exercise 6.5. The question is, prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares on its diagonals. What is given in the question? We are given rhombus ABCD. So given is rhombus ABCD and diagonals AC and BD which intersect at the point O. And since in a rhombus diagonals bisect each other at 90 degree, all these angles are 90 degree. Now we have AC is perpendicular to BD and OA is equal to OC, OB is equal to OD. What is to prove? Sum of the squares of the sides of a rhombus means AB square plus BC square plus CD square plus DA square is equal to sum of the squares of its diagonals. What are diagonals? AC and BD. So AC square plus BD square. Now we have four right angle triangles. Now we use the triangle AOB. In triangle AOB, angle AOB is 90 degree. So now we can apply Pythagoras theorem to get AB square is equal to OA square plus OB square. Let this be equation number 1. Similarly, we can prove in triangle BOC, BC square is equal to OB square plus OC square. Similarly, in triangle OCD, CD square is equal to OC square plus OD square. In triangle AOD, AD square is equal to AO square plus OD square. Let this be equation number 3 and 4. Since we want the sum of the squares of the side, now let us add the equations. Okay, now let us add equation number 1 and 2 and 3 and 4. So in LHS we get AB square plus BC square plus CD square plus AD square. In RHS OA square plus OB square plus OB square plus OC square plus OC square plus OD square plus OD square plus OA square. Careful in writing. Now let us convert here. Observe that two OAs are there. So we have written 2 OA square, 2 OBs are there, 2 OB square, 2 OCs are there, 2 OC square, 2 ODs are there. So 2 OD square, that is equal to what we have to do now. Observe OA and OC. 2 OA square and OA is equal to OC, isn't it? We have been given diagonals bisect each other. So now we can collect 2A OA square plus 2 OC square, that is equal to 4 OA square, and we can collect these two, add these two. OB square and OD square are equal. OB and OD are equal, isn't it? So we can add these two. Instead of OD we can write OB square. So 4 OB square. 4 OA square can be written as 2 OA the whole square. Root of 4 is 2 and here 4 OB the whole square can be written as 2 OB the whole square. That is equal to 2 OA means OC. Observe the diagram. 2 OB means OD. So now we can write it as AC square plus BD square. This is what we have to prove. Sum of the squares on the sides of the rhombus is equal to the sum of the square on the diagonals. So, hence proved.